Okay, so for the last paper of this session, and remember to hang around for the round robin session on husbandry afterwards. We have Kenny Hooker from Thanksgiving Point Butterfly Biosphere. And Kenny, for his bio, says he's a lover of all animals, especially invertebrates and herps. The animals that he most wants to see when he's here are vinegaroons, tailor-swift scorpions, and a Gila monster. Would be amazing. We've had some rain, so you might see a Gila monster. Let's welcome Kenny. He's going to talk about grabbing water scorpion rearing by the Raptorial claws.
How do I put this up? Oh, there we go. I got to give all credit for my title to Marissa, my boss. She came up with it. So anyways, hello, everybody. My name's Kenny. I'm the lab manager at the Butterfly Biosphere at Thanksgiving Point. Today, I would like to talk about my recent project of rearing water scorpions in captivity, which I have also written a short paper about, which if you scan that QR code right there, will go to mine and I think Marissa's paper, maybe just mine. So a little bit of, I have this. Wha-bam. So a little bit of natural history. Water scorpions are small, stick-like aquatic hemipterans that are in the genus Ranatra. They are widely distributed throughout the world, but are most highly concentrated in the Americas. They prefer slow-moving fresh water, and they have siphons at the base of their abdomen that they breathe from, and raptorial forelegs that they hunt their prey with. Water scorpions. So why water scorpions? They make a great exhibit at our institution because they camouflage very well and typically don't cannibalize as adults. So you can have lots of individuals in the same enclosure, and they're very fun to watch hunt. They utilize their raptorial forelegs to capture their prey similarly to mantids, which everybody loves mantids. And although being available online with some regularity, we decided to try to rear our own water scorpions to reduce the impact on wild populations and to have a large enough population to replace any deaths on exhibit as needed. So for our general husbandry, our water scorpions are housed on exhibit as adults, and their setup is pretty simple. They're housed in a standard 10-gallon sized glass aquarium with gravel, a small corner filter, some floating cork bark for egg laying, some faux plants, and various hides that have small sticks glued into a sinking base to kind of replicate reeds that they would normally grasp onto, so it gives them a good foothold. For feeding our water scorpions, they're ambush predators, so we don't really have any live aquatic invertebrates that we could put in with them, so we tongue feed all of our water scorpions. We tongue feed them 3 times a week. They get crickets, waxworms, roaches, houseflies, pretty much anything that gets in front of their face, they will grab onto and try to eat, including your hand sometimes. I've had them try to get me. They make a great exhibit on their own as a single species exhibit, but they also do great with other species like sunburst diving beetles or sometimes small fish. I do not recommend housing them with whirligig beetles. Our first batch of water scorpions, we decided to put them in our multi-species exhibit, and within like 3 days, our first ever adult water scorpion that we reared got its siphon cut in half and died. So don't place them in with whirligig beetles. They will kill the water scorpions. They're just kind of rambunctious little beetles. We give all of our aquatics water changes twice a month. That includes a filter cleaning and gravel vacuuming. And the water temperature is unregulated. We don't have any heating elements. We don't have any cooling elements. So their water temperature is about the same as our gallery, which is 20.5 to 22 degrees, 22.5 degrees Celsius, which is 69 to 73 degrees Fahrenheit. And let's see if it plays. I have a short video of me tongue feeding one of our water scorpions. So they just grab on with those forelegs, and then they pierce it with their rostrum, and takes like an hour to finish feeding. But I have a little picture of one feeding as well. So for reproduction, this species, to my knowledge, is not easily sexed. So in order to get them to breed, we keep all of our adults in the same enclosure. And we just provide floating pieces of cork bark for egg laying. The females will exit the water and they'll stand with their little arms sticking up. It's really cute, and they'll lay their eggs in the crevices of the bark. The eggs can be laid in small batches of just like 1 or 2, or sometimes I've seen 50 eggs laid overnight. So I'm not sure how many they really lay per female, but I'd like to get to know that information one day. For our egg collection protocol, whenever keepers see eggs, they will collect them, or they'll tell me and I'll collect them. We will set up the eggs in a little plastic bin full of water. No filters, no bubblers, nothing. This species cannot swim very well, especially as juveniles, so we've learned that if we put any filters or bubblers, A, they just don't like it because they prefer slow moving or still water, and B, they'll get sucked into a filter pretty easily. So no filters as juveniles. The incubation period for this species, we really haven't been able to figure out what it is. We haven't recorded it officially in the past. Sometimes it takes a couple days, sometimes it takes up to a month or 6 weeks. But we haven't been able to have the record keeping to be able to keep that information like actually recorded. But for our population management of our juveniles, when 15 hatch, we freeze the rest of the eggs for population management. When the newborns hatch, they are taken out of that plastic bin and set up into a glass aquarium. They get their own little floating cups so that they're separated, because they will cannibalize as juveniles, and we're trying to get as many to adulthood as we can. So we have them all separated. As you can see, the little floating cup set up, and I have a picture of a first instar newborn. The cup is just a small, or like a large condiment cup from a deli that we drill holes into and put a strip of cork board on so that the lip is above the water so the water scorpion can't get out. And then we give a small piece of cork bark for footholds. Each individual is tracked with a unique number. So the numbering system is a 5-digit number. The first 2 digits indicate the year hatched. The third is the batch number, and the last 2 digits are the hatching number in order. So the number 24101 is the first hatchling of the first batch of 2024. For feeding our newborns, it's pretty much the same thing as the adults, except for we just use much smaller prey items. So like fruit flies and pinhead crickets have been working well for us. We do tongue feed them because they are really bad at using those forelegs when they're newborns. They go through 5 instars before adulthood. Each instar takes 10, 8.7, 11, 11.9, and 13.6 days respectively, with the total time it takes on average to reach adulthood being 54 days. Once mature, our adults are given 48 hours, 2 days to harden completely. They're painted with a little dot of nail polish. You can see the picture on the left. The water scorpion has a pink dot. I think that's the first water scorpion that we ever had reach adulthood for us. So the painting is so that we know what generation they came from. So pink was our first generation, blue is our second generation, and I don't think we've painted our third generation. For our obstacles, deaths have been a huge problem for us. They usually would die in their first instar right before needing to molt. You could tell they were about to molt because they'd reject food. That was pretty typical throughout all the instars, is the day before, if you gave them food and they rejected it, they were gonna molt or they were gonna die. And we really don't know why they would die. Some of our hypotheses are that they hadn't gotten enough energy to molt and just died in their exoskeletons, or it could be caused by bad genetics due to inbreeding because we didn't have a huge sample size or a huge size number of adults, or it could be caused by water temperature. We really don't know. So if you have any suggestions on what you think it could be, meet me later. And although it's likely unknown what the success rate of reaching adulthood in the wild is for this species, our success rate is about 22%. So it could be really good, it could be really bad, we really aren't sure, but we're pretty happy with 22% of our newborns reaching adulthood. And for our next steps, we will likely keep a few hatchlings in a group so that they'll cannibalize and the strongest survive, which sounds horribly morbid, but that'll help us avoid premature egg euthanasia and provide a food source for the siblings that cannibalize their brothers and sisters. And we will also probably investigate the effect of water temperature on the eggs. And, ooh, not yet. The water temperature on the eggs, juveniles, and adults will also probably try to increase the number of adults that we house so that we have a larger gene pool to assess the problems with inbreeding. And we began this project in September of 2023. I meant to mention this in the beginning. So since then, we've raised, I believe, 12 water scorpions to adulthood. So it's been a fun project. And last but not least, I'd like to acknowledge the entomology team at Thanksgiving Point. So all of my coworkers and bosses for great record keeping and daily husbandry of this species, as well as input on what steps to take for this project. Thank you.
Thank you, Kenny. Few things are cuter than baby Ranatra.